Alright, today we're going to be talking about 10.3, which is the arcs of circles, and we can see our objectives for today is to understand different types of arcs, to find the measure of arcs, and to understand the relationship between congruent arcs, chords, and central angles. So first we'll start out with just identifying some of these. So the central angle is an angle whose vertex is at the center of the circle. So that would look like something like this. So if we have our center here, and I draw in a central angle like that, so it's starting at the center of our circle, and we know that the measure of this angle always equals the intercepted arc. Okay, so whatever the measure of this arc is going to equal the measure of this angle. Okay, and then moving on, we have a semicircle. So we're pretty familiar with this. This is just an arc whose endpoints are the endpoints of the diameter. So if this is the center of our circle, and our diameter goes through the center, then this arc would be right here. Okay, and we know that a semicircle always equals 180 degrees. Alright, and if we're going to label this, we might say this is point A and point B, and then we'd have to have another point somewhere on our arc to identify which half of the circle we're talking about, so we call this X. So you could call this arc AXB with the arc symbol, or BXA. So you can go either direction for that. Alright, next we have a minor arc, and this is an arc whose points are on or between the sides of a central angle. Okay, so that would look like this. We have our central angle right here, and we call this point A and this point B. The minor arc is going to be this arc right here. So they're on or between the sides of the central angle, and we would call this arc AB, or we could call it BA. Alright, and since this is less than a semicircle, we know the measure of a minor arc is always going to be between 0 and 180 degrees. Alright, and then the opposite of that would be a major arc. Okay, so that would look something like this, where we have, let's say we have point T here, and M, and the major arc would be on or outside of the central angle. Okay, so this is outside of the central angle, and to label this just like our semicircle, we would need another point to distinguish it from the minor arc over here. We don't want that one, so we could have another point. We'll call it A. So we could call this arc MAT or TAM. And then since this is bigger than a semicircle, we know the measure is going to be between 180 degrees to 360 degrees. Okay, so to practice using these labels, I want you to look at this diagram and name each thing we have marked here. So I need you to pause the video for a moment and look at the diagram and try to name each one, and then when you play it, we'll have the answers up. Okay, so you can see our answers up right here. You should just be able to go through and check your answers. The only one I want to point out is this last one, angle DBA. This is from last chapter, the inscribed angle, so make sure you don't mix that up with the central angle. But you should be able to go through and just check your answers for that. So moving on, we have some definitions and theorems we need to talk about. The first one is two arcs are congruent if they have the same measure. Alright, so this works when we're given two different situations. So the first one would be if we're given two congruent circles. So we would have circle O is congruent to circle P. Okay, so this one would be O, and then we call this one P. And let's say we have from M to A measures 60 degrees. And then over here we have T to H also measures 60 degrees. So then in our conclusion we can say that arc MA is congruent to arc TH because the circles are congruent. Also, this works if we have congruent arcs have the same measure on the same circle. So here we're given circle O, okay, and let's say we have from J to A is 30, and then from C to K is also 30 degrees. Then we can conclude that arc JA is congruent to arc CK. Okay. Along with that, I do want to point out the difference between the measures of arcs being congruent and the lengths of arcs. So here we could say we have circle C, and let's call this B, and this point A, and this D and F. So if we have this central angle measures 120 degrees, and then we have that this arc is 120 degrees, so BD, and AF is 120 degrees. We know the measure of AF, of arc AF, is congruent to the measure of arc BD, but that doesn't necessarily mean the lengths are congruent. So the lengths AF and BD are not necessarily congruent. Okay, so there's a difference between the measure of the arcs and their lengths. Okay, so keep that in mind. Next, we have a bunch of different theorems kind of summed up in this statement. So this is saying that congruent chords are congruent to arcs, are congruent to central angles. Okay, so we're going to go through some examples and look at them individually. So first we have number 1. So here we have congruent chords. We can conclude that the central angles are congruent. So we can see that we have this chord right here is congruent to this chord over here. So that means that these angles are congruent. So we have x equals 70 degrees. Okay. The next one, we have congruent chords and congruent arcs. So we have this arc measuring 70 degrees, this minor arc right here. So then this central angle also measures 70 degrees. Okay, so to figure out the measure of this major arc on the outside, we're just going to do 360 minus 70 to give us 290 degrees. But we can see that these chords are congruent. So then we know that these arcs are also congruent to each other. Okay, so we can just divide this by 3 because we have 3 pieces right here. So 290 degrees divided by 3, which will give us 96 2/3 degrees for each of those arcs. Okay, moving on to number 3. Here we have pretty easy one. We have our central angle and its intercepted arc. So we have our central angle right here. which measures 160 degrees. So then we know that this minor arc is going to be the same thing. So we know S equals 160 degrees. And then lastly, so we have that this, we have congruent chords, which tells us that these arcs are also congruent to each other. So we know this measures 130 degrees. So to figure out what this minor arc measures, we're just going to do 360 minus 130 minus 130 minus 20 to give us 80 degrees. So that's what this last arc equals. And then since we have a minor arc and a central angle, we know that y is also going to equal 80 degrees. Alright. Then we have a few more problems here to kind of put everything together. So in number 5, we have that AB equals CD, and then PO equals 8. So this is from the last section. So since these chords are congruent, we know that PO is congruent to OQ, so then OQ also equals 8. And then in number 6, we have that AB is a diameter. So then we know this whole arc is going to measure 180. So to figure out the measure of arc BC, we're just going to do 180 minus 110, which would give us 70 degrees. So then we can say that 2x equals 70 degrees because this is a central angle and a minor arc. So then we have x equals 35. Alright. And lastly, we're going to be finding arc AB, AC, and BD. So here we're going to start with AP and BP, which we know are both radii of the circle. So we know they're congruent to each other, which means that this is an isosceles triangle. So we know that this angle is 25 degrees, and since they have to add up to 180, if we do 180 minus 25 minus 25, that is going to give us 130, okay, for this angle. And since this is a central angle, we know that this arc, its intercepted arc right here, is also going to equal 130. So now we know these two arcs, so to figure out what the rest of the circle has to be, we're going to do 360 minus 130 minus 65, which would give us 165. So then, since these two chords right here are congruent, right, we know that these arc AC is congruent to arc BD, so we're just going to do 165, what's left, divided by 2, to give us 82.5 for both of these arcs. So to sum up what we were looking for, we have arc AB equals 130 degrees, arc AC equals 82.5, and arc BD equals 82.5 degrees. And that sums up your 10.3 notes.